today. Let's go ahead and get on with the next assignment. This next assignment is Introduction to Text Identification. It's pretty cool thing if you ask me. The idea is we're able to read in some text and then you go and say, here's another piece of text. Which one is this? So here are three very famous authors from American and English literature. Actually, he's French, she's very English, and he's very American. Jules Verne wrote things like 40 Leagues Under the Sea, Journey to the Earth. He was, you could say he's the grandfather of modern science fiction. Jane Austen, she is very, very important literaturely wise. She wrote things like Pride and Prejudice, and she was one of the most important people in the history of women's literature, opening the door to letting women publish. And then we have L. Frank Baum, and he wrote the Oz series. He wrote all 14 of the original Oz books, the first 14 before he died because he had a heart condition. And you can find these different authors and in here. What we're going to do is we're going to be, if we download this training set, go ahead and save it and then open it up. We're going to see that we have this exact structure. So you have, Verne, and he has those books, and Austen has those books, and Baum has those books. And if we look in those books, we can, with our own eye as a human, look through and say, for example, Austen has a couple of words such as the word lady. She uses lady all the time, like in Pride and Prejudice. Lady, what is, she's very formal with lords and ladies and all those kind of things. And Verne is all about nuclear radiation and that kind of thing. And Baum, well, he uses the word Oz all over the place. And so what we're going to do is we're going to see if we can train the computer to recognize Verne's works from his 4 books, Austen's from hers, Boston and Baum's from 4 of these. Each of them wrote many other books. And so we're going to see if we read those 4 in, say these are Verne's, these 4, these are Austen's, these 4, these are Baum's, then we're going to ask the question, if I give you another book, and all of the books will be from Gutenberg, right here. For example, we can go to Verne's, and all of his original ones are in French, but I promise to only give you the English ones, and they can only be from Gutenberg. That's my promise. So we'll have Gutenberg books from one of these authors. And so the gist is we're going to read in a whole bunch of these, and then I'm going to give you another unknown one or several unknown ones, and you are supposed to say, okay, who wrote this? So the general gist is, okay, read in the training sets from the zip file that I will have, and then, it'll be unzipped, and then training's done. What would you like to identify? And then I give you the name of the book in TXT form that is just downloaded from Gutenberg. And then you are going to use, and this is where it comes in, you're going to at least use naive Bayes and SVM, support vector machines, to do it. You're also going to use 2 other algorithms. And the idea is every single one of these algorithms will tell you its choice. And then you, for just a few points, not very many, I think, you will actually make your own choice of which algorithm you think is best. So part of it will actually be what you actually decide, because in this example, algorithm 1, 2, and 4 all said Verne, but this one said Austen. So what do you say? And you could just, have your own a little decision tree saying, well, if 3 out of 4 of them say this, then I'll go with that, or whatever you want. So the gist is you're reading in these books, and then you are going to be given another book, and you will decide what it is. You have to use at least 4 different algorithms. Now, I have a lot of material on this. So if we start on modules, and we scroll down to machine learning and go all the way down to text identification, then I've got a lot of PowerPoint on how to do by naive Bayes, how to do SVM. But I want to look at 2 of these right now, and I've got lots of examples here. But here's newsgroup classification, which I've already gotten up right here. So there's the newsgroup classification. I downloaded that. And if I run this, what we're going to do is we're going to take a news group, just some posted data, and the atheism group, the Christian group, a computer science graphics group, and then a medical group. And then I can go through and I can, I've got this big tutorial here for you, and I'm going to, through count vectorization, bag of tricks, bag of words, and all sorts of different things, I'm going to figure out who actually said it. And so if we have these 4 different groups where I do this training and everything, and then the 4 groups are atheism, Christianity, graphics, and medical, which one is God is love? If I say God is love, who would you say that would be? I would say it's probably Christianity. OpenGL on the GPU is fast, and that's probably going to be graphics. And so we're going to use Naive Bayes to actually run that. Since this has become an online course, I have lots and lots of tutorials, as I always do, lots of comments, so you should be able to read the comments and see how this actually works. But in general, once I do it, I'm downloading the data set, and that's nice. It's 14 megabytes, so depending on my own speed here at home, it might take a little while to download that, which is kind of annoying. So we're downloading. While it's downloading, let me go ahead and actually talk about this. There are a lot of different ways to make this work, but I'm going to let you read through that. So, was it right? God is love. Is that for Christianity? Yes, in fact, it was. And OpenGL, is that graphics? Yes, it was. So it's pretty cool. I mean, we had, I think, 2,200 different entries with 35,000 words, and it was able to predict it pretty well. So that's pretty cool. I'll let you read through that. This other one that I have, text identification, you can look through there. I recommend you go through my entire series of information. I mean, there's a lot to go through, but all of these work in text identification, multiple algorithms. That one is right here. And this is the same general idea, but what I have, if I go all the way up, is same kind of concept. I've got atheism, Christianity, graphics, and medicine. And then I go through and I talk about bag of words and count vectorization. You'll want to read that and understand that. And then what I'm going to do is I'm going to transform it. And then I do Naive Bayes, see how that works. And then I talk about a pipeline, which is really cool, where I can take all of the different parts, the vectorization, the transform, and Naive Bayes, and just do it, boom, all at once. And so when I do a text CLF, instead of having to do a number of steps, I can just say, okay, I want to do, boom, all of these at once. So I go ahead and say fit, and then I can predict it. I do the same thing with the SVM, which is a very cool thing as well. This is another type this is SVC. So I've just given you a lot of different examples. This one's random forest. This one's logistical regression. So if I run this with a whole bunch of different algorithms, Python 3, now I shouldn't have to download the data set again. I just run it, and you can see how all of the different algorithms work and compare against each other. So Naive Bayes with this data set, with the large number that I tested against, it got, about 83% right. Then I've got stochastic gradient descent with linear SVM, and that got 91%. Just regular SVM without the stochastic got slightly higher at 92%. Random forest did really poorly at about 94%. And logistical regression got about 90%. So some of them were definitely better than others. And as you go through this and learn about it, it's really cool. I've got lots of material on it, and I hope you enjoy this assignment. I've given you more time than if we actually were in class. So it's due April 5th, but if you email me if you have any questions, I hope you enjoy the assignment, and good luck. Don't get sick.